Everything in Flutter is a widget. This is a phrase that you'll hear Flutter developers use because ultimately your entire application is abstracted into a tree of widgets. Flutter has a ton of built-in widgets, some of which are low-level building blocks and others which are all-in-one solutions that solve common problems. Creating a UI in Flutter means combining these building blocks into your own custom widgets. We'll be looking at a wide variety of these built-in widgets in the upcoming videos, but right now I just want to talk about the two lower-level abstractions used to create your own custom widgets. There are two main classes in Flutter that you can extend to build your own custom widgets, the Stateless widget class and the Stateful widget class. The fundamental difference between the two is that the Stateless widget is immutable, meaning that the properties defined inside of it will never change. But that doesn't mean you can't use stateful widgets to handle dynamic data. There's a lot of different built-in mechanisms that can trigger rebuilds of the UI. And we'll look at those as we get further along in the course. So more often than not in Flutter, you'll find yourself building stateless widgets. In fact, when we build out the entire quiz app, you'll find that we only use one stateful widget in that entire application, even though it contains a lot of dynamic data and a lot of user interaction and animation. Now let's go ahead and take a look at the code inside this stateless widget. Inside this widget, we implement a build method, and that's where we define the actual UI. And that's why the build method always has a return type of widget. Now, another thing you'll notice is that the build method always has an argument of the build context. Every widget in the widget tree has a build context, and it's basically just a reference to where that widget lives in the entire application tree. It'll come into play later when we get into navigation and also sharing data deep within the widget tree. Let's go ahead and return a container from our build method, and then we'll give it a width, a height, and a color. So the end result is just a red box. Currently, this stateless widget doesn't have any input properties, so whenever it's rendered, it's always going to look exactly the same. But this widget will be rebuilt multiple times throughout the lifecycle of the application, so we can give it different behavior by passing input properties through its constructor. We'll go ahead and declare a property called color, and we'll make it final because it is immutable. Then constructors in Dart use the same name as the class definition, and we can make color a named argument to the class, and we can optionally set a default value here as well by saying equals colors.red. And then we'll add color down here as the argument to the color of the container. At this point, if we do a hot reload, we'll still get a red box here, but if we go up to the parent widget and then pass in an argument of the color blue, then we'll override that default value with the blue color. Now, one last thing I'll point out is that when you build a stateless widget or a stateful widget, you might see this optional key argument that then calls super on the key. We're not going to have to deal with keys in this course, and it's something that you rarely have to deal with, but you may want to keep that key in the constructor, especially if you're rendering out multiple stateless widgets in a list. Flutter can use the key under the hood to ensure that the list maintains the correct order when there are state changes. But if you only render a single instance of a widget at a time, then you probably don't need the key. So to summarize a stateless widget, it's simply a class that allows you to describe part of your UI, and it does not have any mutable state. Now let's go ahead and convert this into a stateful widget using VS Code refactor. When we run that change, you'll notice that it takes our code and refactors it to extend a stateful widget instead of a stateless widget. And then it also overrides this method called createState, which returns an instance of the state class. The first class we're looking at here is very similar to the stateless widget. We can pass properties into it, and those properties will be immutable. But we don't actually define any UI in this class. Instead, we go down here to the widget state class and define the UI there. Inside this class, we can define mutable state, like we'll go ahead and define a count that starts at 0. Then we'll go ahead and remove the container and replace it with a button so we have some sort of event that can change the state. We'll add some text to the button, and then we can use this $sign here to interpolate the integer value inside of the string. The count is an integer value, but the text widget requires a string, so that's how we can convert it from an integer to a string easily without any extra code. Then the button has this onPressed callback, which allows us to run code whenever the user taps the button. For performance reasons, we don't just re-render the widget anytime a property changes. Instead, we explicitly call setState. This is exactly how things work in React.js if you've ever used that. But the basic idea here is that it gives us a very explicit way to tell the widget when it needs to re-render. Or in other words, it tells the widget to call its build method to reflect the new value in the state. In our case here, every time we press the button, it will increment the value by 1, so we see a different value in the UI here. So the bottom line here is that a stateful widget has some internal data that we can change and manually trigger a re-render of the widget. But one other special feature of a stateful widget is that it has lifecycle hooks, specifically init state and dispose. Init state allows you to run some initialization logic, for example, if you need to retrieve some items from the database and then set them as a property on the stateful widget. And then dispose runs after the widget is removed from the widget tree, so you can do things like unsubscribe from a stream, or end a user's connection to the database, or something along those lines. Now, as you can see, a stateful widget is a little more sophisticated and can be used to orchestrate data changes within your app. But just because you have some dynamic data that's going to change over the lifecycle of the app doesn't necessarily mean that you need a stateful widget to manage it. We'll talk more about this in the state management video later in the course, where we look at different ways to manage data without building a whole bunch of stateful widgets.